So this is my review of the spring 2022 Common Exam number 1 for Calc 2. I'm just going to go over all of the problems and explain how to do them. So for number 1, find the length of the curve, and they give us an equation and they give us a domain. So y is equal to 1 over 6, 2 plus 4x squared, 3 over 2, and they give us a domain of 0, 3. And so over here, the most important part is the length of the curve. So we're looking for arc length. So the formula for arc length is L is equal to square root of the integral from a to b, the square root of 1 plus f prime of x squared dx. Now, the way my professor taught it to me, I think is a really good method, is that you want to do all the work from here outside and then plug it in at the end so you don't mess up all the work jumbled into this, right? So I'm going to do right over here y prime, so the derivative. So I'll write it as f prime of x, since that's the notation I've used before. So f prime of x. So we're going to leave 1 over 6 out, take the exponent, 3 over 2, leave the inside part the same, 4x squared to the 1/2 times, and take the derivative of the inside, which is 8x. Alright, I can see I can cancel some things. That will cancel with that and leave 2. That can cancel with that and leave 2. So f prime of x is equal to 2x, and I'll just write it as that, 2 plus 4x squared. Now I'm going to square it, f prime of x squared. If you look back, that's literally what this is, so that's why I'm squaring it, which is equal to, so I take this first part and I'm just going to square everything, so 4x squared. And for the second half, we can just cancel out the square root with the squared. So we're left with 2 plus 4x squared. And I'm just going to simplify this. So which is, and I'm basically by distributing this factor into the other two. So I get 8x squared plus 16x to the 4th. Now, lastly, for this underneath part, we're going to add 1. So f prime of x squared plus 1. And I'm going to rewrite this with the highest ordered term. So this term in the front, I'm going to have 16x to the 4th plus 8x squared plus 1. And right off the bat, I'm able to tell that there's something I could do with the factoring. So I'm going to look at the terms I can make with this, the first term, this one, and the last term. So over here I'm going to write this in yellow, 16, 8, 4, 2, and 1. And obviously for the last term it's just 1. And since I wanted something squared so that it would cancel out with the square root, I'm going to take this 4 here, which is my most likely answer. 4x squared plus 1 squared. And if I want to double check, I can come off to the side over here and just do a little bit of the FOIL method. So it's 16x squared plus, no, 16x to the 4th actually, plus 4x squared plus 4x squared plus 1, which is the exact same thing. So that's what this is equal to. F prime of x squared plus 1 is equal to that. And now that I have this whole term completed, I can go back to this original equation right here and plug that in. So L is equal to the integral from, and I'll just put in 0 to 3, which is the domain they provided, square root of 4x squared plus 1 squared dx. That squared would go away with the square root. So L is equal to the integral from 0 to 3, of 4x squared plus 1 dx. L is equal to, and now I can just evaluate the integral. So this is 4x cubed over 3 plus x evaluated between 0 and 3. L is equal to, and just now is just plug and play. So 4 times 3 cubed over 3 plus 3. Yeah, 3. And then that's going to be minus 0. Because this term plugged into both of these is 0 and 0. Which is equal to 9 cubed is 27. Divided by 3 is 9. Times 4 is 36. Plus 3. L is equal to 39 units. And that is how you do the verbal. So I'm going to quickly grab the question for the next one. Throw that in here. Oops. Bring that over. The region between the curve y is equal to e to x plus y is, oh my god, y is equal to e to the x plus e to the negative x between negative 1 and 1, and the x-axis is revolved around the x-axis to generate a solve. So they gave this formula between this domain and this bound, and it's revolved around the x-axis, and find its volume. So, if you're not already familiar with this graph, it looks like a parabola. And if you go back to parent functions, which is the thing over there, you should know that. If you don't know it, it's completely fine. You can use test points, especially since it's only between negative 1 and 1. So if you put 0 in for x, you're going to get 1 for this plus 1 for this, so it's 2. And if you put 1 for x, you're going to get e to the first plus e to the negative first. So yeah, it looks exponential here. And same thing for the backwards. So it's literally just a parabola. And so, let's put some bounds up. X is equal to negative 1. I'm going to write that as around here. Well, x is equal to 1. X is equal to negative 1 and the x-axis. And so now from that we can make out this shape. Find the volume. I'm going to use the disk method. Why? It's just simply the easiest one to use in this case. Washer is good too, although you're going to get the same thing. Cylindrical shell also works. But I'm going to use disk. So the formula for the disk method, v is equal to pi, the integral from a to b. Oh, and one more thing. We're rotating around the x-axis. So we're going to be using dx. So pi, the integral from a to b of r of x squared dx. Pretty straightforward. R of x in this case, use a different color, a little bit different, is the difference between the axis of rotation, which in this case is this x-axis, and the graph itself. So that's just y or f of x in this case. So v is equal to pi, the integral, and I'm going to plug in the values. Actually, what I'll do, since this is a even function, which means it's symmetrical across this y-axis, what I can do is I can write a 2 in the front, and set the new limit as 0 to 1. And this is, if you don't remember, it's fine. You could put negative 1 and 1. It will still give you the same answer. But this is a little trick you might have learned from Calculus 1. So 2 pi, the integral from 0 to 1 of y squared dx. And so since this is dx, we can't simply put y squared. But luckily for us, they gave us the value of y, which is this formula right here. So I'm going to go ahead and plug that in. So v is equal to 2 pi, the integral from 0 to 1. And please note this is not for, I'm going to write that down, not cylindrical shell. Cylindrical shell. It's not for the cylindrical shell method. This is simply because of the new bounds that we set for ourselves. So this y squared will become e to the x plus e to the negative x squared dx. Let's evaluate that. I keep going down, but I should go right. Which is equal to 2 pi, the integral from 0 to 1. And don't put e to the 2x immediately. Remember that this is a FOIL, right? This is e to the x plus e to the negative x times another e to the x plus e to the negative x. So what you get is e to the 2x, or e to the x squared, plus 2 e to the x, e to the negative x, plus e to the negative 2x dx. Luckily for us, these two will cancel out to get 1. So 2 times 1 is just 2. Why? If you're quickly questioning, e to 1, any power, so it's like e to the a times e to the b is equal to e to the a plus b. In this case, this is negative 1, and this is 1. I said that backwards. This one is 1, this one is negative 1. So they add up to 0. So let me just rewrite this. V is equal to 2 pi, the integral from 0 to 1. And now I could just rewrite e to the 2x plus 2 plus e to the negative 2x dx. So v, and now this is simply, I can evaluate this. So 2 pi, this is e to the 2x over 2 plus 2x plus e to the negative 2x over negative 2 evaluated between 1 and 0. And this time I can't simply, like in the last one, I didn't write down the 0 over here because I knew it was all 0, but over here, since it's e to the 2x, I should have to write it down just to double check. So v is equal to 2 pi, and so let's write out e squared over 2 plus 2, put that in parentheses, e to the negative 2 over negative 2 minus e to the 0, so I'm just going to put 1. 1/2 plus that's going to be 0. Oh, and would you look at that, it's actually negative 1/2. So I didn't need to write that, because this and this will cancel one another, so this whole thing will be equal to 0. V is equal to 2 pi. And is there any way I could simplify this? So you got e squared over 2 plus 2 minus 1 over 2 e squared. And the answer is probably not. I could distribute the 2 pi, but I'm sure it's fine there. So it's units cubed. That's the answer. So that's number 2 completed. I'm going to quickly take a screenshot of number 3, which does have 2 parts, and number 3 isn't going to be on this exam, but I'll do it anyways just to explain it. Oops. That popped up right over the answer. So number 3, split into 2 parts. So A, they give us this function and they want us to find the derivative. So this is going to be a product rule because this is one part and this is the other. And it's going to include a little bit of chain rule as well. So if you don't remember, u prime v because UV prime is how you do it. I'm sure there's little songs and stuff that you can also memorize, but this is the formula that you need to know. So dy over dx is equal to, so the derivative of x, actually I think I could just rapid fire this part. So cosine of h of 2x plus x, and now it's going to be a little bit of a chain rule, so you got 1 over ln of hyperbolic cosine of 2x times sine of h of 2x times 2. Okay, so dy over dx is equal to, I'm going to rewrite this part because that's going to stay the same, plus, and I'm just going to simplify this a little bit. Oh my god, what am I doing? Not ln. This is the derivative for ln. Right, so 2x, and I can simplify this into hyperbolic tangent. Once again, you don't need to know this since this isn't going to be on the exam, but I guess it's good to know. Oh, and for this, for wondering why there's no negative sign, from hyperbolic sine to hyperbolic cosine, we write this as sine of h of x goes to cosine h of x. There is no negatives, including the backwards as well. This applies for both the integrals and the derivatives. There's no negatives. That's part A. That's the answer for part A. Part B, which is also hyperbolic cosine, so they give ln of 2 and 0, 2 e to the x cosine h of x minus e to the 2x dx. That's a good question. Once again, you don't need to know this, but I would say let's try defining cosine h of x by its formula, e to the x plus e to the negative x over 2, which, by the way, that's the parent function of one of this other question right here, e to the x plus e to the negative x, except this time there's going to be a division by 2. So I'm going to re-plug that in, see what we'll get. Ln of 2 and 0, so 2 e to the x plus e to the negative x over 2 minus e to the 2x dx. That will cancel with that. I'm going to distribute that. Ln of 2, oh my god, my pencil. Ln of 2 and 0. I'm going to distribute this to both like parts. So e to the 2x, and that's again, it's going to be plus 1 plus negative 1. So it's going to be e to the 0, which is just 1, minus e to the 2x dx. And look at that. This and this can also cancel out. So all you're left with is literally ln of 2, 0, 1 dx, which is just x evaluated from ln of 2 to 0, which just means it's the ln of 2, which is really nice. That's a really good question there. Alright, next one. I'm going to move that there. Number 4. Draw a force of F, and they give this equation, is applied to move an object across the x-axis from 0 to 4. Determine the amount of work done. So I have this little line here with 0, that's 4. I have some box that's being moved, and it ends up over here. That's the initial, that's the final. So they gave this function f. F is equal to x over the square root of x squared plus 9. And they're asking for work. So work is equal to the integral from a to b of f of x dx. They already gave us f. They already gave us the domain, which is from 0 to 4. So all we need to do is plug it in and answer. So w is equal to the integral from 0 to 4. Oh my god, this pencil. From 0 to 4 of, and just plug this in, square root of x squared plus 9 dx. This is a u substitution. Well, you could do it. No, you can't. This is only u substitution. So x squared plus 9 du is equal to 2x dx. And we're going to redefine the limits here. If you don't know what I'm doing, you should know. So basically what we'll do is that we'll put the value of x into this equation of u, and define a new limit. So u is equal to 4 squared plus 9. 16 plus 9 is 25. When x is equal to 0, u is equal to 9. And so that comes from here. Right, all we're doing is plugging in 4 into this, and then 0. So let's rewrite that. W is equal to the integral from 9 to 25 of 1 over the square root of u du. W is equal to, and then we'll evaluate here. So we get 2 square root of u evaluated between 9 to 25. W is equal to 2 the square root of 25 minus the square root of 9, which is just 5 minus 3. So it's equal to 2 times, 5 minus 3, yeah. So it's 2 times 2 is 4. And so then the units here is pounds per foot. There we go. Next question. Oh shoot. That's not right. Where'd I put the question? Oh shoot. Okay, quick movement. So, number 5. The region enclosed by the curves y is equal to x plus 2, y is equal to negative x plus 2, and x is equal to 3 is revolved around the line x is equal to 6 to generate a solid. Find the volume using the shell method. So, they tell us to use the shell method. They gave us 3 lines to use as the boundaries, and they gave us the axis of rotation as x is equal to 6. So let's draw ourselves a quick little graph, quick little diagram to, help us out. So you have x plus 2, something like that. You have negative x plus 2, so it passes through this point, right? You have x is equal to 3. I'm going to use a little bit of a different color, which I assume is somewhere around here. And then we have x is equal to 6, which is somewhere far off, right? Draw these all lines. And we want to generate a solid and then use the shell method. So the shell method is pi Oh, and this one is going to be our axis of rotation. Since it's vertical and it's parallel to the y-axis, we can say that we are going to be using dx for the shell method, and only for the shell method. All of the methods we would be using dy. So 2 pi, the integral from a to b of r of x, h of x, dx. Pretty straightforward. If they didn't tell us to use the shell method, we could also use washer here, the washer method, so that's fine. Oh, and let me just draw this out. This is the region that we want. So let's start defining them. So I usually like to start with h of x before r of x, although it really doesn't matter. So h of x is always going to be parallel to the axis of rotation. So this is right here is the axis of rotation. This right here is the axis of rotation. So you want to find, I'll use the green or something, just to show. You want to find the difference between up and down between inside of this boundary. So in that case, we would say it's going to be the top function minus the bottom function. Right, so it's going to be x plus 2 minus negative x plus 2. That's going to cancel, that's going to cancel. So h of x is equal to 2x. Pretty straightforward. R of x is the difference, and I'll use blue for this one, from the axis of rotation to the graph. So in that case, it's going to be like that. Oops, a little too far. To the graph. And this value is going to be determined by, we're going to take the total value of this, which is 6. And we know that because this is x is equal to 6, right? So this is difference of 6. So it's going to be 6 minus x. Because this value right here is x, right? And so if we remove that from this total value of 6, we get this gap that we want. All right, and so let's do that. Let's put 6 minus x into the equation. So now let's just put both of these into the equation. V is equal to 2 pi, the integral from, and I'm going to quickly look back. Okay, so they gave this as 3, and obviously this is the first intersection point is at 0. So from 0 to 3 of 2x, 6 minus x, dx. So v is equal to 2 pi, the integral from 0 to 3, we'll distribute that 12x minus x squared dx. And now we can just evaluate. 2 pi stays outside. We got 12x squared over 2 minus x cubed over 3. Evaluated at between 0 and 3. That's going to cancel out. That's going to become 6. So v is equal to 2 pi. And so if you plug in 0, it's going to be 0. So we don't even need to worry about that. Let's do 6 times 3 squared minus 3 cubed actually. 3 cubed over 3. V is equal to 2 pi. That's 9 times 6, 54. Minus 27 over 3, which is 9. Okay, which is basically just 45. So it's 2 pi 45. So V is equal to 90 pi units cubed. Okay, pretty straightforward stuff. Number 6. At least I would hope it's straightforward. I don't know how straightforward this is truly for every person. Number 6. Here's a surface area problem now. Find the area of the surface formed by rotating the curve, and they gave us this curve, as well as the domain around the x-axis. Okay. Pretty straightforward. Find the area of the surface formed by rotating the curve about the x-axis. So the area formula is something we can start out with. Area is equal to 2 pi, the integral from a to b of f of x, the square root of 1 plus f prime of x squared dx. This right here is the same thing as the arc length formula. So if that helps you remember better, it's a great way to. How do I get rid of this? Okay. So let's just put it in. So let's do the same exact method that we did for the arc length here as well. So y prime is equal to 1/2. I'm going to put 6x minus x squared to the negative 1/2 now, times, and let's put the inside derivative, which is 6 minus 2x. Right? I can rewrite this just to be a little nicer. 3 minus x over the square root of 6x minus x squared. Right? And now we're going to square this. Oops. Y prime squared is equal to, okay, so we have 3 minus x on the top. So you have 9 minus 6x plus x squared over, and we'll just remove that square root down there. Squared. And then let's add that 1. Y prime squared plus 1 is equal to, so I'm going to rewrite this real quick. 6x minus x squared. And instead of writing 1, I'm going to use this bottom part right here again. And I'm going to write it over itself. So that way I can add them together. And this is still 1 because it's still the same. One thing divided by itself is always 1. So we're still in the clear. But now, when I do it, this x squared will cancel with this x squared. This 6x will cancel with this one. So all we're left with is 9 over 6x minus x squared, which is pretty convenient. So back to our equation, area is equal to 2 pi, the integral from, and it's from 1 to 3 of f of x, which is square root of 6x minus x squared, times the square root of 9 over 6x minus x squared. And I'm going to skip the step where I distribute the square root. Actually, I'll just rewrite over it. That's the same thing as this, right? Because you can distribute it. And what you'll notice is that this and this will be able to cancel with one another. So a is equal to 2 pi, the integral 1 to 3 of literally just 3, dx. So I'm going to pull up the 3 and just leave a 1 there. So 6 pi, evaluate it for x between 3 and 1. I'll skip the math. It's 3 minus 2 is 1. No. Oh my god. Don't skip the math. 3 minus 1 is 2 times 6 pi. You get a is equal to 12 pi units squared. Pretty good stuff. Number 7. And we're almost there. Just a couple more questions. Well, 2 more questions. So up to 9. Base of a solid is the region bounded by the curves y is equal to square root of x, y is equal to 0, x is equal to 4. The cross sections perpendicular to the x-axis are squares. Find the volume of this solid. Okay. We're going back to the very first lesson, 6.1, volume using cross sections. It's that one. It's that one that's right over there. Right. And so we have, this is supposed to be a little quick drawing, something like that. This is y is equal to 0, and some value x is equal to 4. So you have that. And it's rotated around it's perpendicular to, it's not rotated, it's perpendicular to the x-axis. So the formula for this one, v is equal to the integral from a to b of a of x, d of x. So these type of questions, the main issue is just finding a of x. There's no memorization of a formula. But, so the area of a square, right, that's what we're looking for, is a side squared. And it mentions that the cross sections are perpendicular, right? So that means it's at 90 degrees. I can't really draw that, but basically the bottom part, well, no, not the bottom part. This right here, we'll use a different color, green. This right here is the base of the square, which means that a of x is equal to y squared. Now obviously, since it's dx, we can't write y squared, so we'll just write the square root of x, because that's what y is, squared, or it's equal to x. So v, the integral between 0 and 4, is equal to x dx, which is, come on. So v is equal to x squared over 2. Okay, my pen just so happened to die. So I'll be back in like a couple minutes. Well, that was fun. Back to it. So we have x squared over 2, the value between 4 and 0. So v is equal to, and obviously 0 squared is 0. So all you have to worry about is 4 squared over 2, which is equal to 16 over 2, which is 8 units cubed. Yeah. That's that. Number 8. A tank is constructed by revolving the curve y is equal to 6x squared for 0 is less than x is less than 1 about the y-axis. So really quickly, if we draw a graph, it's going to look something like that. So about the y-axis, so I'm going to take yellow, just draw around the y-axis. And it's basically something like that. The tank is filled with a fluid weighing 20 pounds per cubic foot. How much work is done in pumping all the fluid to a level 2 feet above the rim of the tank? Okay. This is our 6.5. That's the stuff over there. I'm going to draw with another line color this thing over here. And this is 2 feet above the highest point of the tank. So the tank's highest point is here, and we need to bring it to here. Sounds straightforward. So the formula is work is equal to the integral from C to D of density times delta V, which is the slices, I guess, of this, right, times the distance, or remaining distance for that matter, times dy. So let's write that out. W is equal to the integral, and some people will make a mistake of putting 0 and 1, but it's important to remember that this is in terms of y, not x. So we have to evaluate this based on x, which is pretty easy. If you put 0 in for 6x squared, it's going to still be 0. So 0 is less than or equal to y, which is less than or equal to, and if you plug 1 in, it's going to be 6. And so this is going to be our new, or our, not new per se, but our limits. And I'm just going to, right underneath, I'm going to start writing for f. And so f is going to represent this right here. If you've taken Physics 1, you may recognize the work formula as force times distance. That's what this comes from. So this is the distance right here. This is the force, which is why the force over here is mentioned like that. You don't need to know that, but I guess it's a little tidbit if you want to connect everything. So F is going to be equal to D delta times delta V. D is pretty straightforward. They give that to you. In this case, it is 20 pounds per cubic foot, 20, multiplied by, and this is where it's going to come in. So, well, this is where the harder part is going to come in. So we need to know that delta V is going to be the area, no, not the area, the volume of a cylinder. So that's pi r squared h. All right, which is equal to 20. We'll remove the pi as well. Seems that's easier. R squared, in this case, is going to be, I'll use a different color, it's green. It's going to be the distance from here to here. And we're going to have to square that. So that's going to be x squared. And h is simply going to be dy. dy. And I'll just remove that as well. Why is it dy? Well, the height of this, well, what we're doing is taking infinitesimally small, I'm not writing that. So we're taking infinitesimally small slabs of this, right? And that's what this integral is there for. And that's what this dy comes from. So you're taking really, really small, thin cylinders. That's where this whole idea comes from. And so, over here we got x squared for the radius, and then for h, we're just going to leave it as dy. You can also put delta y if that's easier. F is equal to 20 pi, and we can't put x squared because it's in terms of y. So we're going to need to rewrite y is equal to 6x squared in order for it to be in terms of x. No, sorry, in terms of y. So y divided by 6 is equal to x squared. And you could square root it, or root it on both sides, but we need x squared anyways, so why do that when we could just leave y over 6 as the value dy. Okay, so there's f for you. So w is equal to the integral from 0 to 6, 20 pi y over 6 times, and now remember, there's still this rd over here. We don't want to forget that. And so the remaining distance is basically, well, it's simply going to be the height of where you want to reach to, which is not 6, by the way, but it's 8, right? Because you want to bring it 2 feet above the rim. So the rim is 6, and we're going to leave this limit at 6, but we want to bring this up to 8, right? And 8 minus y, dy. Sound good? Let's keep going. W is equal to 20 pi. The integral from 0 to 6. I'll also bring out this 2. So 20 pi, that can be 10 over 3, 10 pi over 3. And I'm just going to distribute that y, so 8y minus y squared dy. W is equal to 10 pi over 3. Let's evaluate this, so you get 4y squared minus y cubed over 3. Evaluated between 6 and 0. W is equal to 10 pi over 3 of 4 times 6 squared minus 6 cubed over 3. And this is going to take a little bit of math, right? So 36 times 4, 24, 4 times 3 is 12, 14. So you got 144 minus 36 times 2. And if you don't understand how we got that, 6 times 6 times 6 over 3. That cancels out with one of those, leaves it with 2. That's 36 right there times 2. And that is 72. 144 minus 72. You got 2. Oh, 72. Great. W is equal to 10 pi over 3. No, 72 is divisible. I don't remember. I don't know by what, but it's divisible. 2, 6 is 12. 4. So it's 24. That's not there. So W is equal to 240 pi. And what are our units? It's going to be pounds per foot. Last question now. Number 9. If I can get the photo. There. Hopefully my pen doesn't die again. So a 20-foot bucket. A 20-foot bucket is lifted off from the ground into the air by pulling in L feet of cable. The cable weighs 4 pounds per foot. If 400 foot-pounds of work are done lifting both the bucket and cable, what is the length of the cable? I'm gonna draw a little diagram. You absolutely don't have to do this, but I think this is pretty nifty. So I'm gonna draw a little, I don't know, little building, kind of. Let me pick a gray color. Should I draw a person too? Might as well. So you have a little person that's pulling a string, or no, a cable. At the bottom of that cable, you have a bucket. That's a big bucket, I guess. It's 20 pounds, not that big actually. Okay, and so the total work total, that this person does is 400 foot-pounds. Or pounds foot. I put pound foot over there, foot pounds, whatever. And so the total is 400 foot-pounds. But that is both for pulling the bucket, lifting both the bucket and the cable. So W total is equal to WB, which is for the bucket, plus WC, which is for the cable, which is pretty straightforward. Now, what are each of these values mean? WB is equal to the integral from 0, because this bottom part is 0, and this top part is L. So this higher point is going to be your L of just 20 dx. That's it. Why? It's because there's a constant amount of force that's applied there. It's not like it's going to change as you come up. Whereas with the cable, it is going to change, because as you pull more cable here, use that gray color again. As there's more cable here and less cable here, let's say I'm going to delete this, throw that bucket away, and it's only halfway there now, suddenly you're still holding the same bucket, right? But you're holding less cable. So that's important. 0L, we're still going to put the density of it, right? So 4 times, and then we're going to put the remaining distance, which is L minus y, dy. Oh, shoot, this is also dy, by the way. Because it's up, down, it has to be in dy. And so both of these are going to equal 400. So let's put 400 is equal to, and then let's plug in for WB, the work done for the bucket, and the work done for the cable. So the integral from 0 to L of 20 dy plus the integral from 0 to L of, I'll pull the 4 out, L minus y dy. And let's evaluate. And that's going to help us out. So you get 20 times L minus 0. So this is 20L. Plus 4 L squared over 2. What am I doing? Oh my god. Ly minus y squared over 2. And I think it's going to be a good idea just to divide everything by 4. So that's going to cancel out. That's going to become 5. And that's going to become 100. So you have 100 is equal to 5L plus Ly minus y squared over 2. Hold on. I need to backtrack. I'm getting ahead of myself. Because what I forgot to do was to evaluate for this, because this has to be evaluated between 0 and L. Again, 0 doesn't count, but L does count. So in the case of where there's y, we're going to put an L. So this is L squared minus L squared over 2, which is the same thing as to write 400 is equal to 20. Well, I could still do that. I'm going to divide everything by 4. So it's 100 is equal to 5L plus, and it's just going to be L squared over 2. Because this is just same thing as 2L squared over 2. Alright, it's kind of common sense there. And just for ease, I'm going to multiply everything by 2 just to get rid of that fraction. So 200 is equal to 10L plus L squared. Just to get rid of this. It's completely unnecessary, this part, but I'm going to do that. And I'm going to bring everything to one side, so L squared plus 10L minus 200 is equal to 0. And now I'm going to factor in. So I'm looking at, L only has one option here. It's just L. 200, the best option for this one is probably a 10 and a 20, plus minus 10, plus minus 20. And since this is a positive number, we have to know this is going to be plus 20 and this is going to be L minus 10. And if you double check, you got L squared plus 20L minus 10L minus 200, which checks out. Right. And so L can be either 10 or negative 20. And now obviously you can't have a negative amount of, or a negative length of the cable, right? So that's out of the question. So L is equal to 10 and the unit is feet. And that is the end of the thing. There's a bunch of formulas that are important to remember, but I would say, there's just a bunch of formulas you gotta remember. I would say 10 or so. So I can write them out at the end as well. Nah, I'm not doing that. But yeah, definitely study, definitely work hard, and you got this.